In this demo you will learn how to migrate containerized application WordPress from IKS Classic Cluster to IKS GNE2 Cluster. So IKS Cluster running on the Classic infrastructure. And it's located in Frankfurt region. Let's see the dashboard. We have deployed WordPress application inside the WordPress namespace. There is one deployment WordPress which is front end of the application. Other is stateful set which is located at back end of the application. Let's check the storage that app is using. So there are two PVCs that the app is using to store the application data. Swift provides you an option to convert this storage and choose another for the replicated application on the target cluster. During the replication, Swift will perform this conversion and replicate all the Kubernetes objects that are a part of this app and create them onto the target IBM cluster. Now let's access the application. This is the Blogger website that we are going to replicate today, and we've created a sample post here for the demo purpose. Now let's check the target cluster. This is the IKS cluster running on the VPC infrastructure, and it's located in the Dallas region. Which is different from the production region because this is the DR use case. Now let's access its dashboard. We recommend that you create Swift server in the same region as your DR cluster, because if some disaster happens in the production region, then you don't want to lose the Swift server and the backups it has. Apart from this, we attached a 20 GB storage to this server. This is needed only for the DR use case. To store the local backup of your application. But for migration this extra storage is not needed. We've installed the Swift application onto this server now. To access the Swift server, you to copy the IP address of the virtual machine and append Swift dashboard to it, and you'll be landed onto the login page. During the installation, we have already set the password for the default admin user, and if you want then you can add multiple users to the Swift after logging into the Swift server. If you need any help with the Swift operations, you can download the guide from here, but now let's log into the Swift server. Since we haven't yet added the clusters to the Swift, we have landed onto the cluster administration page. Let's add both the clusters to the Swift. Let's add production cluster first. Similarly, let's add DR cluster. Both the clusters have now been added. So let's expand the IKS production cluster, which has an application deployed. Here you can see the summary of the cluster, like the version and other details. If we go to the namespace, we can see the list of namespaces that are present on the production cluster. If you want to see the list of objects of another kind, then you can select the kind here. Let's select Persistent Volume Claim. There are two PVCs that are present on the WordPress namespace on production cluster. Now the next step while setting up the DR is to configure Swift storage. So for that, you need to create a storage pool. Let's give a friendly name Backup Pool. And here's the full list. All the block storage devices that you can add to the pool. And if in case you are not sure whether you are adding the correct device, you can always connect to the Swift server over SSH and cross-check the details there. Let's add this device and create the storage pool. It has been created. To check its status, you can expand it and check the summary here. Now let's go to the DR policy and provide a name to the policy. There are three types of policies you can create on the Swift. Pass-through is meant for the migration and the recurring sync use case. If you want to take a backup of your application, then you need to create a stage 1 policy, and for DR use case you need to create the stage 1+2 policy. Now it's a combination of stage 1 sync and stage 2 sync. Stage 1 sync basically will pull all the application's metadata and the data onto the Swift server, and stage 2 sync will push the application and objects onto the target cluster. Both these can have their separate schedules. Let's provide the schedule for the stage 1 first and for the stage 2. Let's select it to execute after stage 1. If you want to receive the alerts for DR sync completion, you need to provide the email ID here and after you provide it. You can also enable this option to receive DR alerts only if something fails. Now let's create a policy. The policy has been created. Now you can directly apply the policy and provide the sync options to do the initial migration and the recurring sync. But we recommend that you first do the migration using stage 1 and stage 2 sync, and then apply the policy to those jobs. Swift provides a lot of customization options that you can apply for your replicated app. Like, if you want to change the type of your service, then you can select the service here and provide the new type, and if you want to change the port of your application service. Here you need to select the service whose port needs to be changed. Then you need to select the port that you want to change. And provide that target port. And after adding this rule will be applied by the Swift during the replication. Similarly, if you want to include or exclude a particular volume from the sync, then you can do it here. There are a lot of options available for the pre-post scripts and the pre-post YAMLs that you can apply before and after the replication. For now, let's start the replication. Stage 2 sync job has now started and it is rediscovering the target cluster to get the latest status of the target cluster. Let's wait for the stage 2 sync and finish. So the sync has now finished. Let's go to the target cluster to check the app. So this is the dashboard of the target cluster. Let's check these services and access the WordPress app. We can now see that the migration was successful. Apply the DR policy to these jobs. Select the policy, click on Apply button. Select the jobs here. Add both of them. Provide the fallback configuration and just click on the Apply to apply the policy. Now, within a few moments, DR policy will schedule the sync jobs. So for that, to go to Sync Administration and All Replications page. You can see here that the DR policy has initiated the sync. Let's wait for it to finish. The stage 1 sync has now finished and the DR policy has initiated the stage 2 sync. Let's wait for it to finish. The first iteration of the DR policy has now finished and the next will start after an hour because we've created an hourly policy. Now let's take a look at the target application. Let's access it. Now we can see that the new post has appeared here and the Delta sync is also successful. Now, let's go back to the DR policy. Now, if in case some disaster happened in your production region and you want to fail over the policy to make the DR site active, you can do it by clicking here. And if there is any outstanding data that hasn't been synced to the target, then Swift will sync data to the target. Since there is none, so Swift will only change the state to the failed over, and to run the failover in test mode you need to check this box and click on the failover. Now we can see that the policy stage has now changed. If you want to fallback the policy, you can click on this button and click on the fallback sync. Since the policy was failed over in the drill mode, it didn't perform any sync operation and simply changed the state. But for a real failover, Swift will sync the data from the local backup to the production cluster. And in this way, we migrated the application and set up the DR. Thank you.